Hello everybody, and welcome back. Today we're going to be talking about Big Ideas, lesson 5.2, but first, I have a little bit of a riddle for you. If x equals 3, y equals 2x plus 1, and 2z equals y plus 1, what do we think z is? This is something that we haven't quite talked about yet, but I believe that if you take some time with this problem, you might be able to figure it out. Take a second and try and see if you can figure out this riddle. What is z? Have you tried it yet? If so, you might have seen the following. Well, we want to figure out what z is, but we can't solve this equation because we don't know what y is. You can't solve for a variable if there's another unknown in your problem. Same with this problem up here. We could figure out what y is if only we knew what x is. Oh wait, we do know what x is. If you solve this correctly, there may be other ways of doing it, but the only one that I can think of is taking x equals 3 and saying, hang on, if x equals 3, could I replace this x with 3? The answer is yes. We end up with y equals 2 times 3 plus 1. Well, 2 times 3 is 6. So this is y equals 6 plus 1. And 6 plus 1 is 7. Well, now if I know that y is 7, I could replace y equals 7 with this y right in here, right? What you could absolutely do is you could take this 7, put it right in here, and then solve the rest. So we would have 2z equals 7 plus 1. 7 plus 1 we know can be reduced to 8. And to get rid of the 2 in front of the z, we want to divide both sides by 2, giving us z equals 4. If you've got z equals 4, you are correct. We had to use a process here that we've talked about before, but we've never really gone in depth about. We had to substitute in 3 for x, and then solve and get 7. We then substituted in 7 for y. So really, the main exercise of this riddle was substitution. Taking something and putting it into another equation. Hopefully, this one was relatively easy for us, or at least once we got started, we knew how to finish it. But I'm going to give you a little bit of a trickier one now. It's going to have to use the same process of substitution, but it won't be as easy. What happens if we had a problem that looks like this? If x equals 3y, y equals 8 minus x, and z equals 3y plus 7, what is z? We might need to use the principles that we learned just a second ago about substitution in order to help us out with this, but it will be a little trickier. Again, pause the video to see if you can do it, or keep watching and I will go through the answer. So again, we want to do a substitution, but there's a problem here. There's no one number that we can get by itself. For instance, in this equation there are 2 variables, so we can't solve it for one of the variables. In this equation there are 2 variables, so we can't solve it for one of the variables. And in this equation there are 2 variables, so we can't solve it for one of the variables. What do? Well, we can still actually substitute. It'll be a little weird, it'll be a little more complicated, but it will still help us arrive at an answer. Let me show you what I mean. Notice how x is all by itself here. That means we can take this 3y and plug it in wherever we've seen x. There's only one other x in the entire problem, so let's plug it in there. That would give us the following. That would give us y equals 8 minus 3y. But look at what this did. It made it so there's only one type of variable we're talking about. We're only talking about y now. So can we solve for y? We can, but we have to get all of our y's together before we do anything. So how do we bring these y's onto the same side? We learned this in Unit 1, but when you have the same variable on different sides of the equation, you have to add, subtract, multiply, or divide to get them onto the same side. So let's add 3y, because that's the opposite of subtracting 3y. That'll cancel it out over here. We end up with 4y equals 8. Can we solve for y? Yes, if we divide by 4 on both sides, those 4's will cancel out. We end up with y equals 2. We're not done yet, but that's a really good start. Because where can we put this y equals 2? Can we substitute that in anywhere? Yes, we can. We substitute it in all the way over here. If y equals 2, that means z equals 3 times 2 plus 7. All we did was we took this 2 and put it in where the y is. Just like how we took this 3y and put it in where the x is. That'll give us z equals 6 plus 7. And 6 plus 7 gives our final answer of 13. Today's lesson is all about substituting in order to solve systems of equations. We're going to be talking about how to do a substitution, as well as how to do a substitution when we don't have a good starting point. So, I'd like you to flip over to your notes now. We are on page 139. We are actually going to be skipping the notes part up here because we already know all the definitions of these. You can skip back to 5.1 or watch the 5.1 video to know the definitions of a system of linear equations and a solution. Just remember that a solution is going to be in the form x comma y. Down here, it lists the steps for solving systems of linear equations by substitution. The key is, if you find this confusing, flip back to page 139 and look at these 3 steps. These will help you get started and show you how to finish the problem. Sound good? Alright, in that case, let's get started with one of these. So, the problem I want us to look at is this. We have one equation here, x plus y equals 3, and we have a second equation here, 2x plus 4y equals 8. Our goal is to solve for x and y. We are going to do this by substituting in. Let's take a look at the steps. Step number 1. We have to get one of our variables all by itself in order to substitute. Just like in this first problem, how x was all by itself, or in this problem, how x was all by itself. When you have a variable that's all alone, you can take whatever it equals and just plug it in. If we had 2x here, for instance, we couldn't do that because this isn't 2x, it's just the variable x. So the key is, we want to get a variable by itself. Notice how vague this is being, though. Solve one of the equations for one of the variables. It's because there's a lot of freedom with this. You have the opportunity to solve either equation for either variable. So you could get x alone in the top equation, or y alone in the top equation. You can get x alone in the bottom equation, or y alone in the bottom equation. It doesn't matter, so you should do whatever comes easiest to you. I'm looking at these two equations, and I'm thinking it'll be much easier for us to deal with just x and y than 2x and 4y. So, what I'm going to choose to do is I want to get y by itself in this top equation. How do I get y by itself in an equation like this? Well, think back to Unit 1. We treat any other variables just like they're regular numbers. We want to get them away from the y. So, how do we get rid of adding x? By subtracting it. We subtract x from both sides of the equation. They'll cancel out over here, giving us y equals 3 minus x. Very nice. What we need to do now is double check. We've solved one of our equations for one of our variables. Y is all by itself at this point, and the other side is simplified. So step 1 is done. Step 2 is to substitute the expression from step 1 into the other equation and solve for the other variable. What do we mean by this? What it means is, notice how we have y all by itself. This is just this equation reorganized or reordered. If we can take this and put it into the second equation, it'll sort of be like combining these two different equations into one solvable equation. That's our goal, is to combine these two into one solvable equation. We're going to take the expression side of this, the 3 minus x, and plug it in where we see a y in this problem. Please be careful when you do this, because notice that this 4 is attached to the y. So that means the 4 will also have to be attached to 3 minus x when we plug it in. So let's do it. 2x plus 4y equals 8. So this would be the same as saying 2x plus 4. Instead of y, we substitute in 3 minus x. To do that, we put it in parentheses to show that 3 minus x is substituting one thing. Instead of a y, we have the entire thing 3 minus x. At this point, notice how there's only one variable in the problem. That means it is solvable. So, let's simplify and solve. First thing we have to do is we need to distribute this 4 across all the terms here. So 4 times 3 and 4 times negative x. That'll end up giving us 2x plus 4 times 3 is 12. 4 times negative x is negative 4x. And that'll still equal 8. What else can we simplify? We can combine like terms. We have 2x and a negative 4x. When we combine them, we get our 12 is still there, but instead of a positive 2x and negative 4x, we have negative 2x, because 2 minus 4 is negative 2. Okay, we're doing well so far. How do we get x by itself in this case? There are two things attached to it. We have this 2 that's attached by multiplication, and we have this 12 attached via, well, technically addition. The key is we want to get rid of any addition or subtraction steps first. This is attached by addition and subtraction. How do we get rid of a positive 12 from the left side? By subtracting 12 from both sides. 12 minus 12 cancels out, leaving us with just negative 2x. 8 minus 12 is negative 4. Now how do we get x all by itself? Well, negative 2 is being multiplied to it, so to get rid of multiplication, we divide. The negative 2's cancel out, and we're left with x equals 2. So for this entire problem, x is going to equal 2. We're over halfway done. We've taken step 2, and we have finished it. We substituted in the expression into the other equation and solved for the missing variable. The last thing is this. If we know that x is 2, can we figure out what y is based on our original equations? We can. All we need to do is take x equals 2 and plug it back into just one of the original equations and solve. Which equation would be easiest for us to plug 2 into and solve for y? Well, it's going to have to be the top equation for me. Let me show you what I mean. If x plus y equals 3, and we know that x is 2, that means this is really 2 plus y equals 3. How do you get y by itself in this situation? Well, you would subtract 2 from both sides. These cancel out, and we end up with y equals 1. So now we have x equals 2 and y equals 1. Once you have both of your equations, both of your solutions, x and y, you write it in the form of a solution of a linear equation, which is x comma y. The final answer is that the solution to this system of linear equations is the point 2 comma 1. That's where those lines will cross. It may have seemed like a lot that we just did there. Really, it's simple solving, just a lot of steps to solve. It'll overall take less time than the graphing problems. In the spirit of that, I would like us to flip the page. I just want us to focus on 2 problems that we are going to talk about together. The first problem I want us to talk about is number 1. It may seem like you'll get a weird solution for one of the variables. Don't worry. That solution is completely normal. I also want us to talk about problem number 18, right here at the very end. You will get fractions for your answers, and that is okay. In fact, if you get fractions, you should know that you're possibly doing it right. So let's try out numbers 1 and 18. We'll come back and discuss them. If you want to skip over this part of the video because you feel like you are sufficiently confident in solving these, you can skip where we'll talk about problem 19. But for those who are unconfident or who just want to test their knowledge, pause the video, try these out, and we'll come back in a moment. All right, let's start talking about these problems. So problem number 1 is nice for a couple of reasons. Hopefully we notice something about problem number 1. If we look back at step 1 of our notes, step 1 tells us that we are supposed to solve one of the equations for one of the variables. You may notice that in problem number 1, one of the equations is already solved for one of the variables. Y is all by itself. This is very nice because it means that we can sort of skip step 1. Step 2 is just to substitute it in to this top equation. So when we substitute in, we're substituting in for the variable y. So we're changing y into 5 plus x, giving us 2x plus 2 times 5 plus x equals 10. This will be a quick one to simplify. All we need to do is start off by distributing the 2 into the parentheses, giving us 2x plus 10 plus 2x equals 10. Well, what can we combine here? Let's start off by combining the 2x's into just one big 4x. So we have 4x plus 10 equals 10, because 2x plus 2x is 4x. Now we got to start getting x by itself. It's being multiplied by 4, and 10 is being added to it. But because of reverse PEMDAS, we know we always want to get rid of any addition or subtraction first. So we subtract 10 from both sides. The 10's cancel out, giving us just 4x over here. 10 minus 10 is 0. Don't worry if you get 0 for one of your answers. It is possible. In fact, if we divide both sides by 4, we will find that it's just simply x equals 0. That's one of the coordinates of your point. That's your x-coordinate. It just means that our point is going to be somewhere on the y-axis. So that's nothing too special. Now comes the moment of truth. We need to plug this x back in to an equation of our choice and solve for y. Which equation would be easiest to plug 0 in for x and solve for y? I don't know about you, but I definitely think the bottom one will be easier. If y equals 5 plus x, and we know x is 0, this is really just y equals 5 plus 0. Well, what's 5 plus 0? 5 plus 0 is 5. So our answer is the point 0, 5. All right, let's talk about number 18. problem number 18 is sort of the opposite of problem number 1. Problem number 1 was one of the easier ones we can tackle. Problem number 18 is probably the hardest one we can tackle. Here's one of the main problems. We don't have a variable all by itself in any of our equations. So, step 1, we need to solve one of the equations for one of the variables. You get to pick the variable and the equation. As we're looking at this, you might see these equations are kind of equal difficulty. Well, if they look pretty equal, you can solve for just whatever variable you choose. Personally, I'm going to solve this top equation for x. But really, you can do any of them. It's whatever you believe is easiest. So I'm going to solve this top equation for x. If I want to get x by itself, I have to ask myself, what's attached to the x? Well, 4 is connected by multiplication, but what else is attached? This 8y is attached by subtraction. We always get rid of addition and subtraction first. So to get rid of minus 8y, we are going to add 8y to both sides. When we do so, we get 4x all by itself equals 3 plus 8y. X is almost by itself at this point, but not quite there. We need to get rid of the 4. How do we do it? Let's divide both sides by 4 since it's being multiplied here. We end up with x equals 3 plus 8y over 4. Do you remember the trick when you have multiple things on top of a fraction and only one thing on the bottom? The trick is, you can split this fraction into two, 3 over 4 and 8y over 4. And can either of these fractions be simplified? Yeah. 8y divided by 4 is just 2y. So x equals 3 over 4 plus 2y. That's it. That's solved for x. I think now you see why this problem is going to be a little bit of a pain. Step 1 is done. We've solved for one of our variables. Step 2 is that we take the expression here, 3/4 plus 2y, and we substitute it in for x in the other equation. So when we rewrite our other equation, it'll be 8 times, instead of x, we're changing the x in for what the x equals. 3/4 plus 2y plus 4y equals 1. When there's only one variable in your equation, you can solve for that variable. So let's do it. 8 times 3/4 is something that you could do in your calculator, but think about it like this. Instead of the word multiply, think of it as the word of. What's 3/4 of 8? Or, what is 8 of 3/4? 3/4 of 8 is 6. So, this will be 6. 8 times 2y gives us plus 16y. We have this plus 4y that's sticking around from before, and that equals 1. 16 plus 4 is 20, so we have 6 plus 20y equals 1. And now we just need to get y by itself. How do we do it? We get rid of any addition or subtraction first. So we're going to subtract 6 from both sides, giving us 20y equals negative 5. How do we get rid of the 20? Well, since it's being multiplied, we divide it out. So we divide both sides by 20. These cancel, giving us y equals negative 5/20. And negative 5 over 20 can be reduced down to negative 1 over 4. We now have our first solution. Y equals negative 1/4. What do we do with it? We're going to take this y equals 1/4, and per step 3, plug it in to an equation of our choice, then solve. I'm going to choose to plug it into the top equation just because, but you could plug it into the bottom equation and you'll get the same answer. So the top equation was 4x minus 8y equals 3. instead of y, let me draw this line to show that these are two separate pieces. Instead of y, I'm plugging in negative 1/4. So what's negative 8 times negative 1/4? Again, ask yourself, what's 1/4 of 8, and then negative times negative is a positive? Well, we know the 4x is going to stick around. 1/4 of 8 is 2. And since we have two negatives multiplying, it's going to be positive 2. 4x plus 2 equals 3. Now we need to get rid of everything attached to the x. We're going to subtract 2 first from both sides. These will cancel out, giving us 4x equals 1. And to get x by itself, we divide both sides by 4. When you do so, we should get x all by itself equals 1/4. If x equals 1/4 and y equals negative 1/4, our point is 1/4, comma, negative 1/4. And that's the end of that one. Very nice. At this point, we are going to get started on problem number 19. This is going to be the last problem we do for today, and it is one of these word problems. Last time, on 5.1, we talked a lot about different methods for rough drafting. We can use the table method here if we would like to. I will choose to do so. So, when we are rough drafting in a couple of equations, or a system of equations, we need to ask ourselves, what are the two measures being taken? For instance, if our problem was about the price of coconuts that we're selling, one equation would represent the number of coconuts we're selling, the other one might represent the price of coconuts. Or if you're talking about miles per hour, one equation might represent the number of miles, one might represent the number of hours. The key is that for two different equations, they should measure two different things. So here's the problem. An adult ticket to a museum costs $3 more than a children's ticket. When 200 adult tickets and 100 children's tickets are sold, the total revenue is $2,100. What is the cost of a children's ticket? So it sounds to me like we're talking about a total revenue here of $2,100. So let's set up one of our equations down here where our total is $2,100. Let's set up an equation here that represents the revenue. In other words, how much money was made. So this row will be for revenue. One of the measures is how much money the place is making. What's the other measure in the problem, though? Well, as much as I would like to set up an equation about the number of tickets sold, we already know how many tickets were sold. 200 adult and 100 children's. So there's no need to make an equation for it. What we don't know are the costs of the tickets. So the other measure here are the costs. Again, we want to figure out what the cost of an adult ticket is and the cost of a children's ticket. Let's start off by talking about the revenue. The total amount of revenue made is going to be however much we make from the adult tickets, however much we make from the children's tickets. If we sold 200 adult tickets, but we don't know the cost of an adult ticket, we can set it up as 200 tickets times whatever the price is, X. We don't know what the price is, so we can just say the price of an adult ticket is X. The cost of an adult ticket, I apologize, is X. So, the cost of an adult ticket should be X in our table too. If we sold 100 children's tickets, but we don't know the cost of a children's ticket, we can say that the total amount of money made from children's tickets is 100 times Y, whatever the cost is. So the cost of a children's ticket will be Y. Here's the deal. They don't give us some sort of total cost of two tickets. If they did, if they told us an adult ticket plus a children's ticket is this, we put it here. But they don't give us that. What they instead give us is this. An adult ticket to a museum costs $3 more than a children's ticket. How can we represent that in an equation? How do we represent the fact that an adult ticket, X, costs 3 more than a children's ticket, Y? Well, we can write out an equation that represents that. X, the price of an adult ticket, is equal to Y, the cost of a children's ticket, plus 3. If you add 3 to a children's ticket, you get an adult ticket price. So that's our first equation. The second equation is a little more self-explanatory. You're going to add together the total revenue from adult tickets plus the total revenue from children's tickets to get your total, right? When you set up, it will end up looking like this. 200x plus 100y equals 2100. Now that these are set up, can we solve these? Take a second and try it out for yourself. If you want to see how it's done, we'll talk about it in just a moment. So pause the video. Oops, sorry, I miswrote this. Let's get down to business, though. We know that x is going to equal y plus 3. And we know that 200x plus 100y is 2100. So, we already have a variable all by itself. It's x. That means we're going to take whatever x equals and plug it into the second equation, giving us 200 times y plus 3 plus 100y equals 2100. We then distribute the 200 into the parentheses, giving us 200y plus 600 plus 100y equals 2100. We can combine these y terms to give us 300y plus 600 equals 2100. From here, we just need to get y by itself. So we get rid of any addition or subtraction by doing minus 600 to both sides. That'll give us just our 300y by itself, equaling 1500. To get y all by itself, then, we divide both sides by 300. When we do so, y equals 5. That means that y, which we said was the cost of a children's ticket, is $5. Technically, we're all set. We just want to know the price of a children's ticket. But if you wanted to find the price of an adult ticket, you could finish the problem. Taking y equals 5, plugging it into the top equation. If x equals 5 plus 3, then the price of an adult ticket is $8. Because we're only asking for the price of a children's ticket, though, we would say the price of a children's ticket is $5. Thank you so much, everybody. Have a fantastic rest of your day.